Hi, welcome back to my class in statistics. For today, we will take up the measures of central tendency. The measures of central tendency are also known as measures of position or measures of location. There are three measures of central tendency. These are number one, the mean, number two, the median, and number three, the mode. These three measures of central tendency are known as such because they are usually located at the center of the distribution of a set of data. And these measures of central tendency are numerical values, or these are items that typically represent the set of data. And today we start with the mean. The mean is the first of the three measures of central tendency, and the mean is also known as average or arithmetic mean. The mean is defined as the sum of the values divided by the number of values. Suppose we are given n values denoted by x of 1, x of 2, x of 3, up to x of n. These are n values, and we would like to get the mean or arithmetic mean or average of these n values. As we said earlier, the mean is the sum of the values, and the sum is indicated by the operation addition, and the sum is divided by the number of values added, and the quotient is known as the mean. So for the set of values x1, x2, x3, x of n, if these values are obtained from a sample, which we define as a part or portion of the population, we define the mean of the sample by this notation, and we read this notation as x bar. X bar is the mean of the sample, and it is the sum of the values. These are the values, and the sum is given by x1 plus x2 plus x3 plus up to x of n. And the sum is divided by n, where n is the number of values given, or the number of data values from the sample. And using compact notation, we indicate the sum or summation of the values from x of 1 up to x of n using this notation, which we read as the sigma, to indicate summation of the values x of I, where I varies from the subscript I varies from 1 to n. Hence, x bar, the sample mean, is equal to summation of the values x of I, where the subscript I varies from 1 to n, and the sum is divided by n. We take one example to apply this formula for sample mean. Consider the following example. A random sample of 5 sticks of cigarettes have the following nicotine content: 0.39 mg, that's milligram, 0.5 milligram, 0.41 milligram, 0.49 milligram, and 0.52 milligram. What is the mean nicotine content of the sample? In this example, our n In the formula for me, the number of data values given is 5. Because we are given a random sample of 5 sticks of cigarettes. And the nicotine contents of this random sample of 5 sticks of cigarettes are 0.9, 0.39 mg, 0.5 mg, 0.41 milligram, 0.49 mg, and 0.52 mg. These nicotine content are the values x1, x2, x3, x4, up to x5. Thus, using this formula for the arithmetic mean or a simple average, we add these nicotine contents of the 5 sticks of cigarettes, and their sum is divided by n, which is equal to 5 sticks of cigarettes. Again, we write the formula for calculating the sample mean, denoted by x bar. X bar is equal to the sum of the data values taken from a sample. In this example 1, in our example 1, the values are the nicotine contents in milligram of a sample of 5 sticks of cigarettes. And the formula for sample mean is given by the sum of these values. The summation of these values is indicated by the Greek letter sigma. Summation of x sub I, where x sub I are the values given, where the subscript I in this example goes from 1 to 5, where 5 is the sample size. We write I is 1 to 5. And the sum of the 5 values is divided by the sample size, 5. We add the 5 given values. We have 0.39. Summation indicates the sum of a set of values, and the sum is obtained by the operation addition. Thus, we write plus 0.5 plus 0.41 plus 0.49 and plus 0.52. And the sum is divided by the sample size 5. In statistics, you are allowed to make use of your calculator. And using your calculator, you get the sum of these 5 values, and you should get a sum of 2.31. 2.31 is divided by 5. Again, using your calculator, you divide 2.31 divided by 5, and you should get 0.462. Now, it is customary that we express our final answer. If the final answer is in decimal number, it is a common practice to express the final answer to 2 decimal places. If we are to round this off to 2 decimal places, after the decimal point, you count 2 decimal places, and the third digit is the number to be rounded off. If the number to be rounded off is 5 or more than 5, we add 1 to the preceding digit, 6. But the number to be rounded off 2 is less than 5, we simply drop 2, and we get 0.46. 0.46 milligram. Thus, the average or arithmetic mean or simply mean of the random sample of 5 sticks of cigarettes with these nicotine contents have an average of 0.46 mg nicotine content. If the data values are taken from a population, the mean is denoted by the Greek letter mu. And the method for obtaining the population mean is the same method used for obtaining the sample mean. We get the summation of the values taken from the population. We denote that values by x sub I. And for the summation of these values, we use the Greek letter sigma. Summation of x sub I, where the subscript I goes from 1 to capital N. Capital N now here is the population size, the number of values in the population taken from the population. And the summation of the values from the population x sub I is divided by the population size capital N. You can see that the formula for computing the population mean is essentially the same as the formula for computing the sample mean, denoted by x bar. But it is important that you use the correct or appropriate notation for mean. If you are calculating the population mean, you should use the Greek letter mu to denote the population mean. And in the formula, the person who is checking your answer will know that you are calculating your population mean, because in the formula you make use of capital N as the divisor, which represents the population size. We now take another example for using and computing the mean. For our second example, consider the following problem. Find the side of a square with the same perimeter as the rectangle, whose dimensions are 5 inches and 9 inches. This problem is a simple problem that you may have encountered in your basic geometry. But this problem can be solved by using mean. First, we show the solution using the concepts from geometry, the concept of perimeter. We are given that the rectangle has dimensions of 5 inches and 9 inches. And the shorter dimension is the width of the rectangle, and the longer dimension is the length of the rectangle. A rectangle is a quadrilateral with 4 sides. The shorter side, we denote the length of the shorter side, we denote by W for the width. And the given width is 5 inches. The length of the longer side of the rectangle we denote by L. And we are given that the length of the rectangle is 9 inches. And by definition, the perimeter of this rectangle is the sum of the dimensions of the rectangle. And the rectangle has 4 sides, but it has 2 pairs of equal sides. The first pair of equal sides are these 2 parallel sides. So the length of these 2 sides will be W plus W, or 2W. And to this sum, we add the lengths of the second pair of equal sides. This longer side has dimension of L plus the dimension of this longer side, also L. We get 2L. And this is the sum of the dimensions of the rectangle, denoted by P for perimeter. Or you can factor out 2, and we get 2 multiplied by quantity W plus L. We now substitute the width and the length. W is 5 inches. We have 2 multiplied by 5, plus the length is 9 inches. And we get P equals 2 multiplied by 5 plus 9 is 14. And 2 by 14 is 28. Thus, the perimeter of the given rectangle is 28 inches. And we want to find the side of a square. A square is also a quadrilateral, all of whose sides are equal. We construct a square, and the length of its side we denote by S. Again, by definition of perimeter, the perimeter of a square is the sum of dimensions of the square. And the dimension of each side is denoted by S. So, to get the perimeter of the square, we add S to itself 4 times. That is, perimeter of the square is S plus S plus S plus S. Or that is equal to 4S. Since we want a square with perimeter equal to the perimeter of this rectangle, which is equal to 28 inches, we equate the perimeter of this square to 28 inches. Perimeter of the square is 4S. And we want a square with the same perimeter as this rectangle, which is equal to 28 inches. And from this equation, we can solve for the length of each side by dividing both sides by 4. And 4 will cancel out from the left side. We get S equals 28 divided by 4 is 7 inches. Thus, the length of the side of the square that we are looking for is 7 inches. Now, we can also find this side of the square with the same perimeter as this rectangle by using mean. And the formula for mean, using the notation for sample mean. X bar equals summation of values. The values are denoted by X sub I. I is 1 to n, divided by the number of values added. For this particular example, the values X sub I that we will use are the dimensions of the rectangle, 5 inches and 9 inches. And we get the mean of these 2 dimensions of the rectangle by adding 5 and 9. Since we have only added two values, the dimensions of the rectangle, we divide the sum by 2. And x bar equals 5 plus 9 is 14. Divide by 2. And x bar equals 14 divided by 2 is 7. 7 inches. Which is the same as our solution when we get S, the length of the side of the square. This is one application of mean for calculating the side of a square with whose perimeter is equal to the perimeter of the given rectangle. We take another example for an application of mean. For our third example, consider the following problem. Miss Pineapple wants to get an average of 96 in 4 quizzes in statistics. What should she get in the last quiz if her first 3 quizzes are 95, 87, and 79? In this problem, we are given the mean or the arithmetic mean or average. And the given average is 96. And we write that as x bar. X bar equals 96. And that's the average that Miss Pineapple wants to get after she has received her score for the last quiz. Perhaps she is running for summa cum laude and she wants 96 in average for her four quizzes in statistics. And there are 4 quizzes in statistics, and that will be our N or the sample size. Because to get the average of the quizzes, we have to add all the quizzes. And so the divisor is the number of quizzes. And the number of quizzes is 4. And in the formula for mean, the divisor is the sample size N. Thus, our N for this example is 4. And we are given that her first 3 quizzes are 95, 87, and 79. Those are the values given. In the formula, they are denoted by x sub I. We write the values given are 95, 87, and 79. These are her scores in the first 3 quizzes, and we want to know what she should get in the last quiz, and that would be the 4th quiz. And we denote that by using a variable x. We let x equals the score of Miss Pineapple in the last quiz or in the 4th quiz. In each of these 4 quizzes, we take 100 points as the maximum or perfect score in a quiz. Again, we write the formula for the mean x bar. X bar equals the summation of the values x sub I. In this example, the values are the scores in the 4 quizzes in statistics of Miss Pineapple, where I is 1, 2, n, and n is the sample size, and it is the divisor. We now substitute x bar equals 96 is equal to, we add summation of the values, summation of the 4 quizzes of Miss Pineapple. We have 95 plus 87 plus the third quiz 79 plus her score in the fourth quiz, which we denote by x. And this sum of the 4 quizzes, we divide by the number of quizzes, 4. And from this equation, we can solve for the value of x, the score of Miss Pineapple in the fourth or last quiz. We multiply 4 by 96, or others would call that as cross multiplication. 96 multiplied by 4. That's 96 multiplied by 4. 4 by 6 is 24. Carry 2. 4 by 9 is 36 plus 2 is 38. Hence 96 by 4 is 384. Is equal to, we add the 3 scores, the first 3 quizzes of Miss Pineapple, 95 plus 87 plus 79. If you have a calculator, you can get the sum of these first 3 quizzes using your calculator, but I will do it manually. We have 5 plus 7 is 12. And 12 plus 9 is 21. And carry 2. We have 2 plus 9 is 11. Plus 8 is 19. Plus 7 is 261. So 384 is equal to 96. 4 multiplied by 96 equals 384. Equals, the sum of the first 3 quizzes is 261 plus the last quiz x. Now from your algebra in your senior high school, this is an example of a linear equation in one variable x. And we can solve for x by simply transposing 261 to the left side of the equation. And when we transpose, we take the opposite sign of the term. This positive 261, we transpose to the left. It becomes negative 261. And what is left at the right hand side will be x. X now is equal to 384. We transpose 261 to the left side, we get negative 261. And subtracting 261 from 384, we get 123. This is the score that Miss Pineapple needs to get in the last quiz or in the fourth quiz if she wants to get an average of 96 in 4 quizzes in statistics. But as we said earlier, the maximum possible score in a quiz is 100 points. Or the perfect score in any quiz in statistics is 100 points. But this result shows that Miss Pineapple needs to get more than 100 points in the last quiz in order for her to get an average of 96. Thus, we conclude that it is impossible for Miss Pineapple to get an average of 96 in 4 quizzes in statistics. Hence, perhaps you can advise Miss Pineapple to be not so ambitious, to just do her best and be happy with what she gets. Now, the question is, what is the highest possible average that she can get in the 4 quizzes? If it is not possible for Miss Pineapple to get an average of 96, what is the highest possible average that Miss Pineapple can get in the 4 quizzes? To get the highest possible average that Miss Pineapple can get in the 4 quizzes in statistics, we assume that she gets a perfect score of 100 in the last quiz or in the 4th quiz. Assuming that she gets a perfect score of 100 in the last quiz or in the 4th quiz, we calculate the average of Miss Pineapple in the 4 quizzes using this notation for sample mean x bar equals the sum of the 4 quizzes denoted by x sub I, where I is 1 to 4 because we are going to add 4 quizzes, and the sum is divided by 4. The first 3 quizzes are given 95 and 87 and 79, and to the sum of these 3 quizzes we add the 4th quiz of Miss Pineapple, which we assume as a perfect score of 100. And the sum we divide by 4. The sum of the 4 quizzes, assuming that the last quiz is a perfect score of 100, is 361. And we divide 361 by 4 because we have added 4 quizzes. 361 divided by 4 to 2 decimal places is 90.25. This is the maximum, the highest possible average that Miss Pineapple can get in the 4 quizzes in statistics. And she will get this average assuming that she gets a perfect score of 100 in the last quiz. But if she fails to get a perfect score of 100 in the last quiz, her average in the 4 quizzes will be less than or smaller than 90.25. But if she gets a perfect score of 100 in the 4th quiz, she will get an average of 90.25 in the 4 quizzes, which is not bad. Maybe she will not receive the summa cum laude honor, but with an average of 90.25 in the 4 quizzes in statistics, she will definitely still graduate with honors. Now we will take another example for computing a mean, but this time we will compute a mean from a frequency distribution table. But before that, I would like to point out the difference, another difference between the sample mean and the population mean. The sample mean, as we said, is denoted by x bar. And this x bar is an example of what is known as a statistic. A statistic without an S. An statistic is a numerical value that describes a sample. And this numerical value is obtained from a data taken from a sample. An example of a statistic is the sample mean. Now, the population mean, which we denote by the Greek letter mu, is an example of a parameter. parameter. A parameter then is a numerical value that describes a population. An example of a parameter is the population mean. This is a value obtained that can be obtained from a population, from the data obtained from a population. And the population mean is a parameter. And as we go on with the lessons in statistics, we will meet more examples of statistic and parameter. Last example for today, consider the following. Given the data below, given the sample data below, compute the mean. These are the given data. In the first column, we have the values. The values are denoted by X. There are 4 possible values in the given set of data, 5, 7, 8, 10. And the frequency of each value is also given in this table. F stands for frequency. The frequency of 5 is 12, which means that in the original set of data, 5 occurs 12 times in the distribution of data. The frequency of 7 is 6, which means that the value 7 appears 6 times in the original set of data. And the frequency of 8 is 9, which means that the value 8 occurs 9 times in the original set of data. Frequency of 10 is 13, which means that the value 13 appears, the value 10 appears 13 times in the original set of data. This table is an example of a simple frequency distribution table. The frequency distribution table is used to summarize a set of data in tabular form, that is, using tables. Now, if you are to compute the mean from a frequency distribution table for ungrouped data, a frequency distribution table for ungrouped data is one that does not make use of class intervals or classes or range of values. In this example of frequency distribution table, there are no range or classes or class intervals given. And if you are to compute the mean from a frequency distribution table for ungrouped data, the formula to use is this formula. We still use X bar because this data represents sample data. And X bar now is equal to summation of Fx divided by n. The difference of this formula from the original formula for sample mean we had earlier is the occurrence of f. The value x is multiplied by f. So we get to compute for the sample mean, we get the sum of the products of the frequency and the value. And we divide the sum of the products by the sample size n. Hence, to compute for the sample mean x bar, we first multiply the h score by the corresponding frequency. And we add another column, a third column for f multiplied by x, or fx. We multiply the score by the frequency, 5 multiplied by 12 or 12 multiplied by 5. 12 multiplied by 5 is 60. 6 multiplied by 7 is 42. 9 multiplied by 8 is 72. And 13 multiplied by 10 is 130. After you get the product, fx, you now get the summation of the products. And to get the summation of the products from this table, you add the values in this third column for fx. 60 plus 42 plus 72 plus 130. And we denote that as summation of fx. Summation of fx equals, we add 0 plus 2 plus 2 plus 0 is 4. We add 6 plus 4 is 10, plus 7 plus 3 is 20. 20, and we carry 2. 2 plus 1 is 3. The summation of the product fx is 304. And this summation of fx is divided by n. And here is the sample size. In a frequency table for ungrouped data such as this table, the sample size is the sum of the frequencies. So you add this second column for summation of fx. N is equal to summation of the frequencies. Add the frequency column or add the values in the frequency column, and you have the sample size. The sample size is the summation of the frequencies if the frequency table is given. So we add 12 plus 6 is 18. 18 plus 9 is 27. And 27 plus 13 is 40. Now we can compute the sample mean x bar for this sample data. X bar now is equal to summation of fx is 304. And we divide by n 40. Using your calculator, you divide 304 by 40. But I do not have a calculator, so I will do the division manually. We have 304 divided by 40 is about 7. 7 multiplied by 0 is 0. 7 multiplied by 4 is 28. We subtract 280 from 304. We get 4 and 2. And we want the answer to 2 decimal places. If you want the answer to 2 decimal places, you divide up to 3 decimal places and then you round it off to 2 decimal places. So after decimal point, we add 3 zeros and we bring down the first 0. 240 divided by 4 is 6. 6 by 0 is 0. 6 by 4 is 24. 0. Bring down the second 0. 0 divided by 40 is 0. 0 by 40 is 0. 0 minus 0 is 0. Bring down the last 0, 0. 0 divided by 40 is 0. 0 by 40 is 0. And 0 minus 0 is 0. Hence the quotient 304 divided by 40 is 7.60. 7.60. This is the mean or the average or arithmetic mean of this sample data that consists of 40 values. 7.60. In the next lesson, we will take another example of a set of data to be summarized and presented in a frequency distribution table for ungrouped data. and we will present them also graphically using a vertical bar graph and a pie chart. If you have any questions for the lessons today, you ask your question in the comments below. And thank you for joining me in my class today. And don't forget to subscribe to my YouTube channel, Art Kalisan.